Hey everyone, this is TechXtreme, and in this video I'm going to talk about how linked lists work and how you can set up your own linked list in Java. So first of all, what is a linked list? Well, a linked list is essentially a daisy chain of nodes that are linked together using some form of attribute that references the data type itself. So, for example, if we have a class called node, we can link each node together, and it doesn't matter what data we have in there or anything like that. All it matters is that we have some form of reference point so that we can link them all together using that reference. And I suppose I can try and get that going for you in action. So within my project folder, I'm going to create a Java class called node. Within this node, I'm going to refer to itself. So we use the data type which infers the class, and we'll call it next. You could call it whatever you want. You call it A, B, C, D, E, F, G. It doesn't matter. Just providing you have something that references the class itself, you can link each quote-unquote node together. And say within this node we want to store some form of data. We're going to store an integer and we'll call it number. Let's create a constructor for this so that we can store our integer. So let's say we have node and it stores the integer number. Within this constructor we can say this dot number is equal to number, and that's that. We can also create a default constructor as well, such that we don't have to actually store anything in it. There's no real use to it because obviously you want to store data within each one, but there might be use cases for it, so I'm just going to leave it in. And our class for our node is essentially complete. So basically, we have two fields. We have node next, we have int number, and this one is the important one for when we want to link nodes together. So let's create a another class and just call this one driver. Call it whatever you want. I'm just going to call it driver, and within it we'll create a method that will allow us to run the code within Java. So that would be public static void main, and within it we're going to have a string array and call it args. There we go. We have somewhere where we can actually run some code. So let's first of all create our first node, and we'll call it node head, and we'll say it's equal to new node, and we'll have it store the number 1. Now within that we can reference the node that we created, which we called head, and we can say head.next, which allows us to refer to the node that we created, and we can actually insert another node into it. So we'll say head.next is equal to new node int number, and we'll say the number 2. Then if we want to add something else, another node to it, another number, we can say head.next, and you can see it's very repetitive. So you might want to think about creating an add method that will allow you to, instinctively add everything together so that you don't have to remember, oh, how many next was I in? But for this example, I want to keep it as simple as possible. So this is what we're going to do. And to show that we have a linked list, we're going to use a temporary variable. So we're going to call it node temp, and we'll have it reference the head. And we'll see that as we traverse through, we'll see the next field being used in order to access the number 2 and the number 3. So node temp is equal to head. You don't want to actually try and scan through it using head, because as you try and do that, you'll find that you'll actually be shortening your list all the way down to just this one node. So the head would become the number 3. So that's not great. So have a temporary variable that will just allow you to scan through the list, and it won't affect your actual list itself. So temp works out here. And we can say something like, while temp does not equal to null, i.e., if temp was equal to null, what would happen is basically you would reach the end of the list, because as you can see here, there is data within head, there is data within head.next, and there is data within head.next.next. Now there is no data, nor does data exist for head.next.next.next, meaning it will end the loop and it won't try and access that data. And this will become clear once I write down the line temp is equal to temp.next. Now this line here allows us to just go through the list. So it starts here, goes here, then it goes here, and then it tries to access the one after it, and then it notices, oh shoot, there's nothing there, it's null, I'm gonna exit the while loop. So that's our last line here, so I'm gonna add something above it, which will be a SOUT, i.e. a system.out.println, which will allow us to print on a new line each time the number within the nodes. So how do we access that? Well, we'll say temp.number. And since this is essentially in the public domain, it will allow us to access our number. Ideally, you might want to privatize it and, have getters and setters so that, things are sort of more locked down. But just for this example, we're going to have it like this. And then after the while loop, we'll do another system.out.println and we'll say end of list. So what we should see is we should see the number 1, then the number 2, not the number 2, I don't know what that is, the number 2, and then the number 3, and then end of list. That's what I'm anticipating. So let's run it and see what happens. Okay, awesome. So we're able to see that it uses this temporary variable, goes through the list without affecting the list itself. Because if we do a line below it and we say system.out.println and we say, I don't know, temp.number, right? We'll see that it will either throw a null pointer exception, which it probably will, and it will say, oh, it's null, or there will be nothing there. Yeah, there we go. So it cannot read field number because temp is null. So you can see that this variable field rather becomes useless if you're going to use it again. You would have to redefine it as the head in order to search through it again from this line. But say if we did use head, right? You'll see that our list will be essentially destroyed. So if I do a line here and we say head.number, right? And I remove this temp.head, or sorry, temp is equal to head, and instead of temp, we use head, head.number, head is equal to head.next. We'll see that we would have essentially destroyed our entire linked list by not using that temporary variable. And I do want to point that out because sometimes, that might happen and you're thinking, oh, why is this not working? So you can see here, the field number cannot be read because head is now null. So essentially our list is gone. But because Command Z or Control Z, if you use Windows or Linux, exists, we can actually fix that. So that when we run this again, we'll see that it prints out the whole list using the temporary variable, and we'll see head.number will actually just equal to 1, which is great for our use. So there we go, the number 1. So nothing, so our list is not impacted thanks to this temp field being used. And I hope that helps explain at least a small bit how linked lists work. Essentially, at the very core, it's just a sort of daisy chain link of quote unquote nodes. Now, you could call this whatever. You could have this called, I don't know, order. You could have certain fields within it, but I'm just using Node just for the example here. But basically, essentially, that's all it is. At its core is just a bunch of quote unquote nodes that link together, and it forms a linked list, hence the name. So if you enjoyed this video, please give it a like. If it wasn't up to stuff, please give it a dislike. Let me know what you think in the comments, of course. And I will see you in the next one, whenever that will be. And yeah, this is TechXtreme signing out. Have a wonderful day.